thing is to get out of one and get into the other in, right on the half hour mark. So
Yeah, that's
usually a few minutes late to each one, but I managed to get into this one at 7:30. So you got stuff you can verbalize?
yes, I do.
Good. Let's do it.
So we're coming into the final test of the semester on Thursday,
Okay.
and it's all about logs.
Okay. And this is the final for the semester.
Yep.
This week, not next week. Okay, cool.
No, this week we get out a week early, but we go back on like the
Earlier.
second or third.
Wow.
Yeah.
Wow. Okay. So let's have the log problems.
So let's go with, how's this? The natural log, and then it's parentheses x minus 4 plus the natural log of 3, like that, yep, equals the natural log of 2x plus 3.
Okay. Whenever you see multiple log statements like this, separated by either a plus sign or a minus sign, you can compress them into a single log statement. I don't mean all three, but I mean just everything that's on the left side of the equation. So
Okay.
if I want to write that as a single log statement, what is it?
So natural log of, and then since it's addition, we're going to multiply.
Okay.
So
by 3 times that, what do you get?
3x minus 12.
Okay.
Equals the natural log of 2x plus.
And now, if I've got the natural log of one thing equals the natural log of a different thing, then those things have to be equal. In other words, I can now set the arguments equal to one another.
Oh yeah, that was fun.
Kind of think of it as dividing both sides by ln, even though that is not at all what you're doing. In other words, when I say the natural log, that's not natural log multiplied by that. It's like f of x. F of x is not f times x. It's just the notation for a function.
Okay.
It says it's a function of the variable x. Well, but there are some tricks that you can pretend that you're dividing both sides by natural log, and that gives you the right conclusion. And then, of course, solving this, you get x equal 15.
Yep.
Now, it's also necessary, once you get your answer, particularly with log equations, to check and make sure you have not violated any domain. If I would have gotten x equal minus 15, well, that violates that domain. You can only take logs of positive numbers.
Okay, so you can only take logs of positive
numbers. It's more restrictive than this function. Y equals square root of x, I can at least take the square root of 0 and positive numbers. But y equal natural log of x, x has to be greater than 0. Up here, x can be greater than or equal to 0. So if you're talking about restrictive domains, log is one of them. Because you cannot even take the log of 0. And this particular answer does not violate any of our domains, and so it's fine. But a lot of times you'll end up with two answers. You'll end up with a quadratic to solve, you'll get two values, and almost always one of them violates the domain. So it's not a solution. Only the solution that does not violate the domain is a proper solution.
Okay.
Got another one?
Yeah.
Probably run into one like that. I'm sure we will.
Yeah, I think we will later on in the packet probably. What about the natural log of x plus 1 minus the natural log of 2 equals 3.
Okay. Again, compress the left side.
Okay. So since there's a minus there, it's going to be division. So ln of x plus 1 over 2 equals 3.
Okay. Now, how do you solve log equations once you get it down to a nice, concise expression like this?
You are going to convert it to the exponential form.
Okay, and what is that conversion here?
So the x plus 1 over 2 is all one unit.
Okay.
The
The way I always do it, if my log function is on the left, then I take that number raised to this power equals whatever's in the middle. Okay, what's the base for natural log?
E.
So it's e to the third equals x plus 1 over 2. And then you just have to solve that for x.
Okay.
So x is going to be equal to 2e to the third minus 1. And you can get that number out of your calculator. Actually, that's a fine answer. There's nothing wrong with that answer either. But you certainly don't have to multiply e by itself 3 times to get it.
Yeah.
Okay. And that also is a positive number. So we're not violating any domains here either. And incidentally, to check whether you violate domains, always go back to the original equation, not that one. They're not going to be the same. You can have answers that violate the domain of part of your original, but they wouldn't necessarily violate this domain.
Okay.
Odd as that sounds, because you're kind of taught that these two equations are the same. In other words, that's the same as that, but it really isn't. If I had the following, the natural log of x plus the natural log of x minus 1, well, that's going to be the natural log of x squared minus x, right?
Yep.
What if I came up with an answer where x equals 1/2? No, that's a bad example. In other words, it's possible for this to be greater than 0, whereas one of these might not be. In other words, if x was 1/2, that's violating that domain right there.
Yep.
And yet, if I plug it into this domain, it might not violate it. So always check your domain violations in your original equation.
Okay.
What else you got?
Yeah, that I'll have to.
I can make one up to illustrate that point if you like, but
No, I think if I just remember.
we'll run into a problem, I'm pretty sure, where we'll have to deal with that.
I think this next one might, but I'm not sure.
Okay.
Log base 2 of x squared plus 8 equals the log base 2 of x plus the log base 2 of 6.
Now, 1 second. The only time that we can apply these log rules is if it's the same base. If one of these bases was not 2, I wouldn't be able to do much with it.
Okay.
What's my first step going to be?
We're going to have to consolidate the right side.
Okay, what does it become?
That becomes log base 2 of 6x.
Okay. And if that's equal to that, then what can you say?
Oh, then we can just drop the logs again.
Right. So we've got x squared plus 8 equals 6x. Let's solve that. Traditional method.
Okay.
I know you know how to do all of this, so I'll speed it up a little bit.
Yep.
If you don't, holler, by all means say, hold it, how'd you get that? Really? They're giving us, oh no,
Is this
it's easy. I was thinking I was going to have to use the quadratic formula.
I thought so for a second too.
Yeah, but no, this factors nicely to that. And again, in other words, this is a very rare one. It's rare that you get two solutions and both of them are fine. But
Oh, yeah.
this is the case. In other words, both of these solutions do not violate that domain and they don't violate that domain. Had one of them come out to be a negative number, boy, they could easily have made that happen too. But they didn't choose to on this particular problem. But had one of them come out to be a negative number, it would have violated this domain over here. And we would have had to throw out that solution as extraneous.
So it has to fill all of the domains in order to
Not violate any of the domains, and that means that the arguments have to be positive once you've filled in the solutions.
Okay.
We'll get to one where that happens, I assure you.
Yeah, I think so too.
We're halfway through, so you may need to skip down to some of the harder ones. But I don't want to force you to skip down if you don't know these. Let's just go through these that we're doing.
Okay. Yeah, here it kind of we kind of get some I'm a little confused here.
Okay.
We get some word problems again.
Involving logs or involving probably exponential decay and growth?
I think so, but I think it might involve logs
Well,
in the end.
with exponential decay and growth, remember your variable is in the exponent.
Yep.
So you generally have to use logs to solve those.
So
Go ahead and read it. I'll see if I can pick up all the pertinent information.
all right. You invest money into an account earning 2.25 annual interest compounded monthly. How long will it take to double your money?
Okay. There's three equations for growth. There is A, the final amount equals the initial amount times 1 plus r to the t. That's for annual compounding. For greater than annual, in other words, more often than annual, it's A equals A sub 0 times what? Do you know this one?
Is that R over N raised to the N times T?
Where N is the number of times per year that it's being compounded. So in our case, N is 12 since it's being compounded monthly. Okay? And they said, how long does it take money to double? Well, what they're really saying is A sub 0 becomes 2A sub 0, right?
Right.
So I'm going to write 2A sub 0 in place of A. That would be a doubling regardless of what A sub 0 was.
Okay.
Plus, got to convert that percent to a decimal. So it's 0.225 divided by 12 multiplied by 12t. And now notice what happens. It looks like we have two variables, a sub 0
Yeah.
and t, but the a sub 0 cancels. So we really only have one variable.
Oh, yeah.
And that's t. And this applies to this kind of a problem, but it also applies when you have radioactive decay and they talk about half-life. Well, with half-life, a sub 0 becomes half a sub 0, and the a sub 0's still cancel. So a lot of times you don't really need to know the initial amount, you just need to know the conditions. If they're saying how long does it take to double, then all I have to do is solve this equation. So
Okay.
what's the first step in solving this equation?
Now
that I've divided both sides by a sub 0.
Solve what is inside the parentheses.
Well, I've got this. I'm just going to leave it written like that because you're going to end up doing this on your calculator.
Okay.
To get this number. But what's the next step? In other words, that's where I'm at this point. In other words, I've got everything that is being taken to this variable exponent is in parentheses. In other words, if this 1 was outside the parentheses, I would move it over immediately. I'm trying to isolate every single thing that's being affected by this exponent. What's the next step in solving an exponential equation?
You would... Oh.
How'd you solve a log equation?
You put it into exponential.
How do you solve an exponential equation?
Put it into logs.
Okay. Let's take the natural log of both sides. And you could actually take any kind of log. I could take log base 2, which might seem easier, but it really isn't. I could take log base 10. I always use natural log. Natural log is the log of calculus. And once you get into calculus, you rarely deal with any other bases. So I just always use it. Now, what can I do?
Now you can...
What can I do it? The whole point of taking logs is so that I can get that variable out of the exponent.
Oh, now you can move that variable down in front of the natural log.
I can turn it into an algebraic equation.
Yeah.
And then this is still 1 plus, and this is just some number that I'm writing the argument for, which means t is going to be this divided by 12 times natural log of 1 plus this number. You see how I get this?
Yep.
And that's your answer. In other words, that's a number you can get out of your calculator, and that'll tell you what t, how long that it takes, and t is in years in this particular case. And the reason it's in years is because they gave you the interest rate on a yearly basis. Even though it's compounded monthly, t is not in months. T is in years in this problem. T doesn't have to be in years. In other words, with a lot of decay equations, t is in days or weeks or minutes or seconds or years. Some things have a half-life of like 3 seconds. Other things have a half-life of 25,000 years. So t is not, the units on t is not predefined by the general equation. Usually when you're talking about compounding and they give you a rate that's on a per year basis, then t is in years. Okay. But you could even, you'd want to simplify that, whatever that decimal divided by 12 is, add it to 1 so that you say the natural log of 1 point something. But that's all you need to do. There's nothing wrong with this answer, actually, exactly as it is. But your teacher probably is looking for some number of years, so you'd want to put that into your calculator and come up with a number.
Okay.
Okay?
Yeah, just simple.
Yeah, let's not worry about the arithmetic. I'm assuming you know how to put that into your calculator and come up with.
Yeah, I'd hope so.
Okay, what else you got, Casey?
I was just looking at this one, and it looks really simple, and I don't know why it's confusing me.
Okay.
Because I think it's going to be really simple. But it's the natural log of 1 over x equals -5. So we just go
Go ahead.
we just go exponential, right?
Right.
So it's going to look like e and then raised to the -5 equals 1 over x.
Yeah, and this I can rewrite as 1 over e to the 5th equals 1 over x. What's x equal to? Not a number.
E to the 5th.
E to the 5th, yeah.
Yeah.
In other words, you
Okay.
can solve that any number of ways. You can cross multiply if you like. But the fact is, if the numerators are the same and there's an equal sign there, then the denominators have to be the same also. So you can immediately say x equals e to the 5th.
Okay. And then for that one, do I need to like verify that?
No, because that's always a positive number.
Okay.
And as long as that's a positive number, then you're fine.
Awesome.
As long as x is a positive number. I didn't mean 1 over e to the 5th. Actually, no, that's true. 1 over e to the 5th has to be a positive number.
Mm-hmm.
All right.
Okay.
See if I can give you one that's got, since we have limited time here, I'm going to make one.
Yeah.
I just got to, let me see if I can figure out how to make this up so that it comes out the way I want. I'm going to leave that blank for just a moment. It's the problem when you are so if I went to solve this, it would be e, and let's make this common log.
Okay.
So it'll be 10 to some power equals x squared minus 1.
Okay.
Let's make it base 8. And this is going to be a 1 over here. Okay? So there's my original equation.
Okay.
There's row 2.
Yeah.
And converting it to exponential gives me 8 to the 1 power equals x squared minus 1, right?
Yep.
Which means x squared equals 9, which means x equals plus or minus 3.
Okay.
The minus 3 violates both those domains.
Yeah.
Notice it does not violate that domain.
No, it doesn't, because the -3 squared is still 9.
Right. So it's possible to violate the original domain, eliminating the minus 3 as an answer, and yet if you thought you might take a shortcut and test that one, thinking that these two are exactly the same, they actually are not. They're almost the same. They're the same in every respect except domain considerations.
Mm-hmm.
And that's why you always have to go back to the original. So the answer is +3 only.
Okay. Yes, you just always got to be careful for that.
You do. Because most of the time when you compress these things, you end up with an x squared. And of course then negative numbers don't hurt because they're being squared. This was always a little puzzling to me because in mathematics you like to think equal means equal.
Right.
But it
I
doesn't
think
actually
that's
in this
equal.
case, not with logs.
No. Huh. That's really interesting.
Yeah,
Because I would have thought,
yeah.
yeah. Hmm.
Of course, and it's not always going to be, I mean, most people make the mistake when they solve for x here, they'd say x is 3. They forget the plus or minus.
Right.
But that's not the kind of thing you're going to be faced with. You're going to be faced with something like this, minus 4x minus 12, say. In other words, you end up with a quadratic, and you get x minus 6 times x plus 2, which gives you a negative solution for x and a positive solution for x.
Right.
So if the original thing was something that looked similar to that, the negative solution almost always is going to violate that domain. Not
Right.
always, but almost always, because it is
Yeah.
possible to have this expression. You can certainly have that. But x has to be a negative number,
Right.
because then that makes your argument positive. So there's nothing wrong with having a negative sign in your argument, but the result has to be a positive number. Otherwise, you violate the domain in the same sense that if you take the square root of a negative number, you violate the domain. The answer, believe it or not, when you take the log of a negative number is, guess what? I, the imaginary I.
Really?
Yep.
Wow.
They
All right.
never teach that to people in high school, but yeah, logs of negative numbers or zero produce imaginary results.
Hmm.
Casey, I might have time for one more if it's quick. I got an 8.
That actually that finishes my worksheet.
Well, good, good.
So
Allow me
I
to
have
my next one.
I've got a test on Thursday, and she's handing out the review sheet on Wednesday. So then on Wednesday night, I'll have probably some more harder ones to throw at you.
Sounds good.
But all right, thank you very much, and I'll talk to you on Wednesday.
30 on Wednesday.
Yep.
All right, Casey. Bye-bye.
Bye.